sequence? Let us see. So sequence basic definition, all of you know. So it is nothing but, a sequence is nothing but a function. We denote it by Fn. In some textbooks, they denote it by Sn or Xn, different notations, whatever it may be. It is nothing but a function whose domain is set of natural numbers and whose codomain is some subset of real number system. So you can call this set as any subset of real number system. It is a subset of real number system. You can call it S, which is subset of real number system. Or you can call it as Xn is nothing but domain is natural numbers. Range is nothing but some subset of real numbers. Range is, this is codomain. It is range is nothing but here some subset of the real number system. So, you know, this is sequence, as we said, discussed Sn, which is nothing but set of natural numbers too, or the range is subset of real number system, and n is natural numbers. So 1, 2, 3, and so on. So this small n, the variable, belongs to the domain. So it is always defined for 1, 2, 3, and so on. So S1, S2, S3, and so on. This is the sequence. So Sn, a sequence is denoted like this. It is from 1 to infinity, which is nothing but S1, S2, and so on, Sn, and so on. So Sn is also there. There is no end in this. This is the required sequence for this. Now, we want to define an example. For example, you are having n ranging from 1 to infinity, let us say, example. Then we are having our S1 as, put n equal to 1. This is 1, 2, 3, and so on. This is m, nth term. Sn is what is called nth term of the sequence. First term is S1, S2, S3, and so on. This is one sequence. Then we define what is called range of the sequence. As we have discussed, it is always a subset of real number system. What is range of the sequence is? Sequence is generally denoted like this. In some textbooks, I have seen a notation like this. In some textbooks, I have seen a notation like this also. So whatever it may be, you should understand that this represents a sequence. So how the range of the sequence is defined is the set of different values. Range of this is set of different values. Sn takes different values of the sequence. See, what are all the different values that are there in the sequence that constitutes what is called as a range. Range is nothing but a set of all different values, distinct values, which are there in the sequence that constitutes what is called range. For example, here, what are the distinct values? Total. You can see 1, 2, 3, and so on. That means, what is the range of the sequence is for this? For example, for this, above example, for this sequence n, what is the range is 1, 2, 3, and so on, because all are distinct, which is nothing but natural numbers. So the range of the sequence n, ranging from 1 to infinity, is nothing but 1, 2, 3, and so on. All are distinct only. So it is set of natural. Okay. And for example, if I take another example, if I take the sequence Sn as 1, 1, 1, and so as a set, it is infinite, but it is a sequence here. Sequence, that is the reason why we don't denote like this. We denote like this. Otherwise, you may think there is no difference between set and a sequence. That is the reason why notation, because generally we use this flower bracket for set. Let us denote the sequence like this to avoid confusion between set and a sequence. Here you can see this is your S1, S2, S3. Nth term is also Sn, that is also one only, and so on up to infinity. N equal to 1, n equal to 2, n equal to 3. So what is the nth term of the sequence here is 1 for all nth term. For n is equal to 1, 2, 3, and so on. This is what is called nth term of the sequence. Now we want to find what is the range. Range of the sequence is sequence Sn. Set of distinct values in this. What are set of distinct values? It's only one. So the set of all distinct values here, there is only one value which is present. All are not distinct, they are same. So singleton. This becomes range of the sequence, which is subset of R, as you can see. So here it appears as if it is infinite, but as you can see, range is defined as set of different distinct values. We consider only distinct. This is a sequence. This is range of the sequence. So let us go for another example. Third one. For example, you have sine n pi by 2. Let us n equal to 1 to infinity. Sorry, I denoted like this habitual. Let us denote sequence like this to avoid confusion between set and this. N equal to 1 to infinity. So what is the sequence then? The sequence Sn is nothing but put n equal to 1, sine pi by 2. Put n equal to 2, sine 2 pi by 2. N equal to 3, 3 pi by 2. 4, n equal to 4, 4 pi by 2. 5 pi by 2, etc. And so on. Okay. Now, what are the values? Nothing but sine 90, 1, sine pi, 0, sine 180 is 0. You know, sine n pi is 0. Sine pi 0, sine 2 pi 0, sine 3 pi 0, and so on. Sine 3 pi by 2, 270. 180 plus 90 minus sine 90 minus 1. This is 2 pi. Sine 2 pi is 0. Sine 5 pi by 2. 5 into 90. 450. Sine 360 plus 90. Sine 90, which is 1. And so on. This will continue. So what are the distinct values it is taking for this? The distinct values it is taking is 1, 0, minus 1, 0, 1. If you continue sine 6 pi by 2, sine 7 pi by 2, you can continue. Then you will get 1, 0, minus 1, 1, 0, minus 1 like that. So what is the range of this sequence? This is sequence Sn. I should use same notation. Here also we use same notation. Both the sides. This is the sequence Sn. Then what is the range of this sequence? The range of this sequence is set of distinct values. There are infinitely many, correct? But they are repeated values. So distinct values are 1, 0, minus 1. Only these three values it is taken. So this is what is called range of the sequence. So sequence means it contains many repeated values also will be there. But the fixed location is fixed. This is S1. Order is fixed. S2, S4, and so on. This is fixed positions. In a set, you know, order not important. I can write this as minus 1, 0, 1. I can write 0, 1, minus 1. But in a set, you can write in any order. It is same as 0, minus 1, 1. But whereas here it is not so. It is having a fixed order. First term must be 1 only. You cannot write 0, 1. It meaning changes. That means first term is 0, which is incorrect. So it is a well-defined order, that is ordered set of real numbers. This is what is called as sequence. Okay. So this is how the range is defined. Next, we go for what is called different types of sequences. One type of sequence generally we find is what is called constant sequence. We come across these types of sequences. Under that, first one we find is constant sequence. We'll be using this generally. What is constant sequences? A sequence in which each and every term equal to a constant. That is a sequence of the form. A sequence of the form k comma k comma k comma and so on. Where k is a constant, a real number. Where k is a constant, a real number, fixed constant. This is what is called constant sequence. Where k is a constant is called constant sequence. This constant can be 0, 1, 1 by 2, root 2, anything, rational, irrational, anything is called constant sequence. We come across. For example of constant sequences, 2, 2, 2, and so on. This is constant. For this, what is the range is? That constant itself. Always it will be singleton. For a constant sequence, range will be equal to that constant term to which it is equal. So what is the range of this is k. Okay, it will be always a singleton set. So finite, obviously. Next, we define what is called, if this constant equal to 0, then also it is called null sequence. Generally, students, they think that if it is equal to 0, then it is called null sequence, but not so. Null sequence is different. Null sequence means the sequence whose limit is 0 is called null sequence. So one of the null sequences is 0, 0, 0, and so on is called null sequence, but that is not the only null sequence. Null sequence definition is a sequence is said to be null sequence if the limit of that sequence is 0. The limit of the sequence is 0. Such a sequence is what is called null sequence. What is meant by limit? We'll come back to that later. But 0, 0, 0, it's a constant sequence called null sequence, but that is not the only null sequence. It is one of the null sequences. Okay. So a sequence of the form is also called as, that is one of the null sequences that I will discuss later. So we go for now. This is equal to 0. I mean, 0. Is a null sequence. I'm not calling it as called null sequence. It is a null sequence. There is a difference. If I call this as null sequence, I cannot call anything else as null sequence. It is a null sequence. That means among null sequences, this is one. Okay, this is a null sequence. A null sequence. That means whenever I use the word A, the article A, that means there are many null sequences. If I say the null sequence, that means it is the only one. A null sequence, that means there are many null sequences. Among them, this is also one. That's what is the meaning. Okay. Now, because all of you are not illiterates with respect to this subject, you can see if the, for example, the sequence 1, 1 by 2, 1 by 3, 1 by n, and so on. This is also null sequence. Why it is called null sequence? Not everything is 0. Limit of the sequence is 0. How the limit of the sequence is defined? Limit of the nth term. Limit n tending to infinity 1 by n is 0. So limit 1 by n 0. If the limit of the sequence is 0, such a sequence is called null sequence. What is the nth term? 1 by n. Limit 1 by n is 0. As n tends to infinity, 1 by n is 0. because limit of the sequence is 0. This is called null sequence. Here also, what is the nth term is 0. Because first term 0, second term 0, third term 0, and so on, nth term 0. Limit of the sequence is also 0. So it is also a null sequence. Because not because everything is 0, because limit is 0. This is also null sequence. This is also a null sequence. So this, I think, it eliminates the ambiguity that 0 is the only null sequence like that. This is null sequence. This is also null sequence. ఇది కూడా null sequence అంటారు. దీన్ని కూడా null sequence అంటారు. నల్ సీక్వెన్సెస్ చాలా ఉంటాయి. లిమిట్ ఆఫ్ ద సీక్వెన్స్ 0 అయితే దాన్ని నల్ సీక్వెన్స్ అంటాం. సో చాలా మందికి మిస్కాన్సెప్షన్ ఏంటంటే ప్రతిదీ 0 అయితేనే అది నల్ సీక్వెన్స్ అన్నట్టు కొంతమందికి మిస్కాన్సెప్షన్. అది తప్పు. సో ఇది కూడా లిమిట్ కనుక 0 అయితే లిమిట్ ఆఫ్ ద నల్ సీక్వెన్స్, లిమిట్ ఆఫ్ ద సీక్వెన్స్ ఈస్ 0, ఇట్ ఇస్ కాల్డ్ నల్ సీక్వెన్స్. సో ఇది కూడా నల్ సీక్వెన్స్, ఇది కూడా నల్ సీక్వెన్స్. ఓకే, దిస్ ఈస్ వన్ ఆఫ్ ద నల్ సీక్వెన్సెస్. నెక్స్ట్, లెట్ us go for what is meant by bounded sequence. So here let us talk about the bounded sequences, then we'll go for limit. So what is meant by bounded sequence? Bounded sequence, because these are all fundamentals for working out your questions. They're alphabets for sequences. So what is the next definition is bounded sequence. When is sequence said to be bounded? The sequence is said to be bounded if the range is bounded. Sequence Sn is said to be bounded, is said to be bounded. Two definitions are there. If first definition, range is bounded. Range of Sn is bounded. It is if and only if. All the definitions are if and only if. That is, if the range is bounded, sequence is said to be bounded. If the range is unbounded, sequence is said to be unbounded. Both the sides. So range of the sequence is bounded. When do we say range is bounded? Range is a set. When is set said to be bounded? We have studied earlier. But anyway, I try to recall. This is one definition. What is definition 2 is, if and only if there exist two real numbers, k1, k2, real numbers, such that Sn is between k1 and k2. Greater than or equal to k1, less than or equal to k2, for all n equal to 1 to infinity. That means S1 should be between k1 and k2. S2 also should be between k1 and k2. S3 also should be between k1 and k2. Then k1 is what is called lower bound, k2 is what is called upper bound. Then we have a type. Definition 3. It is if and only if a sequence is bounded, if and only if sequence is bounded above as well as bounded below. As well as bounded below. A sequence is said to be bounded if and only if it is bounded above as well as bounded below. So when do we say it is bounded above? That I should. So a sequence is said to be bounded above, if there exists a constant, let us say some constant, k2, let us call it k2 or k anything, such that Sn is less than or equal to k. K is a real number, constant, fixed real number, such that Sn is less than or equal to k for all n. For all n means, always remember your small n values are 1, 2, 3 and so on up to, and so on. It continues, natural numbers. So Sn takes values S1 less than or equal to k, S2 less than or equal to k, and so on. Then it is said to be bounded above. What is the example of a sequence which is bounded above? For example, So let me complete this, then we'll go for examples. A sequence Sn is bounded below. It is said to be bounded below if and only if there exists a constant L belonging to R such that Sn is L is less than or equal to S for all. If this is so, L is called lower bound. And if there exists a real number L which is less than or equal to every member of the sequence, such a real number is called a lower bound. If a lower bound exists, we say the sequence is bounded. This is what is called lower bound of the sequence. This is the upper bound of the sequence. If there exists upper bound as well as lower bound for the range, then we say the sequence is bounded. That is, if the nth term is bounded above, that is less than or equal to some constant k, then k is called the upper bound for the sequence. If the nth term is greater than or equal to L for all n, L is called lower bound for the range, for that range. If the range is bounded, then automatically sequence is bounded. So we say this is the lower bound for the sequence and the k is the upper. So if there exists for the range, if there exists lower bound and upper bound, it is said to be a bounded sequence. Bounded above as well as bounded below, then it is a bounded sequence. Let us see an example. Let us see. Is the sequence question? We'll work out many. Is the sequence? తెలుగులో కూడా. సో Sn bounded above అంటే Sn nth term is less than or equal to k అయితే, k అనేది ఒక రియల్ నెంబర్ అయితే, ఈ k ని మనం అప్పర్ బౌండ్ అంటాం. ఈ కాన్స్టెంట్ కనుక ఎగ్జిస్ట్ అయితే we say sequence is bounded. And if there exists ఒక రియల్ నెంబర్ L కాన్స్టెంట్, if there exists a real number L such that L is less than or equal to Sn అయితే, L exist అయితే we say sequence is bounded. ఇది సీక్వెన్స్ బౌండెడ్ అది. ఇది బౌండెడ్ ఎబో అయ్యి బిలో కూడా అయితే దాన్ని బౌండెడ్ సీక్వెన్స్ అంటాం. ఇప్పుడు 3 డెఫినేషన్స్ చూసాము. ఏంటా డెఫినేషన్స్? ఫస్ట్ డెఫినేషన్ ఏమని చెప్తుంది? రేంజ్ ఈస్ బౌండెడ్. రేంజ్ అంటే ఒక సెట్. వెన్ ఈ సెట్ బి బౌండెడ్ ప్రొవైడెడ్ దెర్ ఎగ్జిస్ట్ లోయర్ బౌండ్ యాజ్ వెల్ యాజ్ అప్పర్. దట్ వీ హావ్ డిస్కస్డ్ ఎలాబొరేట్లీ ఇన్ ద ప్రీవియస్ classes. So what is meant by upper bound? So second definition is if and only if there exist constants k1 and k2, real numbers exist also. K1 it should be Sn should be between k1 and k2 అయితే ఇప్పుడు k1 lower bound of k2 upper bound. So if the nth term of the sequence is between two constants for all n, that is S1 less than between k1 k2, S2 between k1 k2 and so on, and the sequence is said to be bounded. థర్డ్ డెఫినేషన్ మనం అన్ని ఉపయోగిస్తాం. కొన్నిసార్లు ఫస్ట్ డెఫినేషన్, కొన్నిసార్లు సెకండ్, కొన్నిసార్లు థర్డ్, కనుక అన్ని నేర్చుకోవాలి. సో Sn is bounded above as well as bounded. Then we say it is a bounded sequence. Bounded above అంటే upper bound exists. Bounded below అంటే lower bound. So lower bound అంటే there should exist a constant L such that L is less than or equal to Sn అయితే bounded below. Bounded above అంటే there should exist a term k, real number k, such that Sn is less than or equal to k. So let us see an example. Example చూస్తే so is the sequence, for example, -5 whole power n. Only notation can carry. Let us use this notation without any confusion. N equal to 1 to infinity. Is the sequence bounded?
Response on anybody? Anyone?
You have to get. So, చెప్తారా ఎవరైనా? What is this sequence? This is nothing but n equal to 1 to infinity. Put n equal to 1. It is nothing but
Unbounded, madam.
Unbounded. ఎవరు చెప్తున్నారు? Akhila to everyone. Can you say what is the range, please? Yeah, I am only telling Akhila. What is the range of the sequence? Put n equal to 1, -5. Put n equal to 2, -5 square. -5 cube. and so on. So this is -5, 25, -125, and so on. Unbounded, Jyoti said. Okay, let us. So is it bounded? Unbounded means what is in the unbounded? And nobody knows. So not bounded, that's it. So let us see if it is having lower bound or upper. Just I asked the question, is it bounded? Bounded means should be bounded below as well as bounded above. Okay. So bounded below, we want to find out the lower bound. Is there any least member in this or not? We want to find out. What will be next one? -5 whole power 4. That is 625. And so on. How to get lower bound, upper bound for this? What is the nth term? -5 whole power n. It is not fixed. So whenever you want to get a lower bound, first let us write the range. What is the range of this sequence? Somebody asked. Range of this sequence. Set of all different values. That is -5, 25, -125, 625, and so on. This is the range. Range is infinite. Yeah. Range is infinite. The set is infinite. But sometimes even in this and so on, infinite also may be bounded sometimes. So you should not see it and so on and conclude. We have to find out lower bound and upper bound. This is a set. We have discussed in the previous classes. How to get lower bound? Always remember, whenever there is minus and plus mixed, lower bound always comes from negative terms. Upper bound always comes from positive terms. Whenever there are mixed terms, divide them. All negative terms you write at one place. And so this is negative. From here you will get lower bound if it exists. From all positive terms, we will get upper. That is greatest among them will be the upper bound. Is there any greatest number? 25, 25 square, 25 power 4, 25 power next 6, and so on. This is increasing. 25 is less than 625. Next number will be less than this. So there is no maximum number for this. There is no highest value which is going to bound this. So there exists no key such that this is bound. Range -5 whole power. Or what is the nth term? -5 whole power. Range of this. Let us call it as some set S. There is exist no K such that every member, let us say Sn less than K. There exists no K such that Sn less than K for all n. Therefore, we say that there is no upper bound. So there exists no upper bound for this. So the sequence is not bounded. So the sequence is not bounded. Why it is not bounded above? Because there is no K such that Sn less than K. If it is less than K, here no is important. There is no K satisfying this. Therefore, it is not bounded above. It is not bounded above. Because there is no highest number which can bound this. Not bounded. Next, lower bound. When is lower bound? What is in the lower bound? Least member. So when you look at it, you know -5 is greater than -125. This will be greater than, it is going like this. Here this is going like this. And so on. Because it is increasing, there is no upper bound for this. This is again -5 greater than -125 and so on. All negative. There is no least term. From negative we will get lower bound. Least of the negative numbers will give you lower bound. Greatest among positive terms will give you upper. There is no greatest term number here. there is no least term here. Satisfied. Therefore, there exists no L such that Sn is greater than. That is L is less than. It can be equal also. For n equal to 1, 2. There exists no number satisfying. Because there is no least negative number. If at all it exists, lower bound always exists from the least among the negative values is the lower bound. The greatest among the positive values will give you the upper bound. There is no greatest term here, so it is not bounded above. There is no least term, so it is not bounded below. Therefore, sequence is not bounded below. Is not bounded below. So if it is bounded above as well as bounded below, then only it is called a bounded sequence. So there exists no lower bound, no upper bound. Therefore, the sequence is neither bounded above nor bounded below. It is an unbound, it is not bounded sequence. I did not define unbounded, so that is the problem. Not bounded. Not a bounded sequence. When do we say it is unbounded? Your friends are using the term. So what is meant by unbounded sequences? Generally, students they have an impression that if it is not bounded above, not bounded below, then it is unbounded. No. A sequence, this itself may be given as a question. A sequence is unbounded if it is not bounded above and not bounded below, or not bounded above, or not bounded below, or both. Like this, options will be given. So it's a definitions you must very, very careful. A sequence, SL, is said to be unbounded, is said to be an unbounded sequence if it is either not bounded above. If it is not bounded above, then also not bounded above, then also it is unbounded. Either not bounded above or not bounded below. Both. Neither. Either not bounded above or not bounded below, or neither bounded above nor bounded. Neither bounded above nor bounded below. So upper bound exists కాకపోయినా unbounded. Lower bound exist కాకపోయినా unbounded. రెండు ఎగ్జిస్ట్ కాకపోతే ఆటోమేటిక్ గా అనుకోండి. సో అన్బౌండెడ్ అంటే ఐదర్ నాట్ బౌండెడ్ అబో అప్పర్ బౌండ్ ఎగ్జిస్ట్ కాకపోయినా అన్బౌండెడ్ సీక్వెన్సే. లోయర్ బౌండ్ ఎగ్జిస్ట్ కాకపోయినా అన్బౌండెడ్ సీక్వెన్సే. లోయర్ బౌండ్ అప్పర్ బౌండ్ రెండు ఎగ్జిస్ట్ కాకపోయినా అన్బౌండెడ్ సీక్వెన్సే. జనరల్ గా అన్బౌండెడ్ అంటే రెండు వైపులా బౌండ్స్ లేవు అన్నట్టు అర్థం చేసుకుంటారు, కానీ తప్పదు. సో అది అప్పర్ బౌండ్ ఎగ్జిస్ట్ కాకపోయినా అన్బౌండెడ్, లోయర్ బౌండ్ ఎగ్జిస్ట్ కాకపోయినా అన్బౌండెడ్, రెండు ఎగ్జిస్ట్ కాకపోతే ఆటోమేటిక్ గా అన్బౌండెడ్. ఓకే, సో ఎగ్జాంపుల్ చూడండి. సో I will give you a list. So question, which of the following are bounded sequences? If not bounded, check. Yeah. If not bounded means unbounded. If unbounded, check they are bounded above or below or neither. Because we have said unbounded means ఎట్లా ఉంటుందంటే స్టూడెంట్ ఫెయిల్ అయ్యాడు. సపోజ్ ఫెయిల్ అయ్యాడు అంటే మొత్తం ఫెయిల్ అయ్యాడా, అట్లీస్ట్ వన్ సబ్జెక్ట్ ఫెయిల్ అయ్యాడా, అది. సో ఇఫ్ అట్లీస్ట్ వన్ ఆఫ్ ద సబ్జెక్ట్స్ ఈ స్టూడెంట్ ఫెయిల్స్, దెన్ ఈస్ ఫెయిల్యూర్ క్యాండిడేట్. ఆల్ సబ్జెక్ట్స్ ఫెయిల్యూర్ ఆల్సో ఈస్ అ ఫెయిల్. అట్లీస్ట్ వన్ సబ్జెక్ట్ ఫెయిల్యూర్ ఈస్ ఆల్సో ఫెయిల్. సో ఇప్పుడు నాట్ బౌండెడ్ అబౌవ్ ఆల్సో unbounded, not bounded below also unbounded, both does not exist also unbounded. So let us take an example first. -1 whole power. Second,
చాట్ బాక్స్ డైరెక్ట్ చెప్పండి, ట్రై చేయండి.
try change at least. One, 1/2, 1/2, and so.
Yes, respond all in chat box. Very good. Good response.
So let us see whether the first one -1 whole power n sin pi/2. Second one bounded is saying n square one 2 power n. Let us see. So someone is saying, respond good.
Response.
1 and 4 are bounded, unbounded, 4 unbounded. Let's check. 1 and 2 bounded. If they are unbounded, why they are unbounded? That's what also I want. So let us check. First one. What is the range for the first one? Range for the first one is okay.
-1, 1, ma'am.
Just what happened?
Respond in chat box, all of you.
Nine, where is my searching? This is
Yes, beta వాళ్ళు కూడా. Good. First one is range is -1 +1.
yeah. I want to get back to my notebook.
Okay.
Something like this. What is the range? So -1 whole power n. As many of you have responded, this is nothing but n equal to 1 -1 square. That is the reason why I have discussed -5 whole power. Generally, students are of the impression when something power and keeping this in the mind, they think bounded. So in the previous question, we have discussed -5 whole power. This is bounded, but whereas -5 whole power n is unbounded, neither bounded below nor bounded above. So don't think of something to the power of n is there, it will be bounded. Some are bounded, some are not bounded, depends on the inside number. So here -1 cube and so on. Is it not? So this is nothing but -1, 1, -1, 1, and so on. So what are the different values the sequence is taking? So the sequence Sn, if we call it, or Xn, -1 power n is nothing but -1, 1, -1, 1, and so on. So here what we observe is, what is the range of this? The range of this is nothing but different values Only two different values it is taking, -1 and 1. This is a set. When is set be bounded? Every member here greater than some constant, that is lower bound, less than something, upper bound. For this, every member here is greater than or equal to -1. So what is the range of this? I call this as some S. Then every member here, Sn, greater than or equal to -1, less than or equal to 1 for all. Because actually only two numbers are there. You know, -1 is less than or greater than or equal to -1. 1 is greater than -1. So therefore, -1, every member here is least is -1. So -1 is lower bound, highest is 1. Both the members are less than or equal to 1. 1 is equal to 1 actually, less than or equal to is also allowed. So this set is bounded between them. Lower bound exists, upper bound exists. Therefore, it is a bounded sequence. So sequence is bounded. But whereas -5 whole power n, when we have taken neither lower bound exists nor upper bound exists, neither bounded below nor bounded above. But whereas here it is having lower bound as well as upper bound. Yes, bounded sequence. Most of you have answered this. What is the ranges? -1, 1. So don't think -2 power n is bounded like that. Only -1 power n is bounded. Sin n pi by 2. Earlier we have discussed this sequence. So sequence Sn sin n pi by 2. Earlier we have expanded. We got -1, 0, 1. These are the only values. N equal to 1, sin 90, already discussed. Sin 2 pi by 2, sin 3 pi by 2, and so on. So this is 1, 0, -1, 1, 0, -1, and so on. So same values will be repeated. Therefore, what are the distinct values it is taking is 1, 0, -1. So range of the sequence is 1, 0, minus. You can write -1, 0, 1 also. You can write 1, 0, 1 also. But here you cannot change the order. This sequence is not same as 0, 1, -1. But whereas this set is same as 0, 1, -1. So you should understand the difference between sequence and a set. Set you can write in any order, but sequence order is fixed. So this is always the first one, fixed. So this is the range. Least is -1, highest is 1. So Sn is greater than or equal to -1, less than or equal to 1 for all. Therefore, bounded. The sequence is bounded above as well as bounded below. So sin n pi by 2 is bounded sequence. Okay, next one. Next we had 1, 1 by 2, 1 by 3. Some are saying something and let us see. Third one. Sequence Sn 1, 1 by 2, 1 by 3, 1 by n, and so on. So all the members here, our observation is 1 is greater than 1 by 2, 1 by 2 is greater than 1 by 3. It is going in this direction. The members, the range of the sequence. What is the range of the sequence? Different values. 1, 1 by 2, 1 by 3, 1 by n, and so on. Range is set of different values. What is the sequence? What is the some sequence they are following? Some property they are satisfying, increasing or some order is there. What is the order? 1 greater than 1 by 2 greater than 1 by 3 and so on. So what is our observation? Generally, students what they are thinking is and so on, therefore not bounded with. Is the impression they are having. One is upper bound. All of you will agree. So all the terms are less than or equal to 1. So because and so on is there, you have a misconception that it is not having lower bound. No. So whenever you get such questions, upper bound exists. If you take limit n tending to infinity of the nth term, you will get the lower bound. As you can see, as n tends to infinity, this is approaching 0. So all are positive here. So the lower bound is 0. It is not there in this. Lower bound need not be in the set. We have discussed earlier. Lower bound and upper bound sometimes may not be in the set, but still they exist. All of them are positive. So lower bound exists. As n tends to infinity of the nth term, if you take, if already upper bound exists, if it is increasing order, limit of this nth term will give you the lower bound. If it is decreasing order, if you take a limit of the nth term, you will get the lower bound. Remember this shortcut. Whenever it is increasing, the limit of this nth term as n tends to infinity, 1 by n is 0, that will give you the lower bound. If it is decreasing, then the limit of the nth term will give you the lower bound. Sorry, upper bound. The other way, upper bound. So if it is like this, S1 less than S2 and so on, the limit of this nth term will give you the upper bound. Because it is in the form the other way, greater, this limit will give you the lower. So this we'll discuss in detail. So it's having a lower bound as well as upper bound. Therefore, the sequence Sn is bounded. It's bounded. Those who said unbounded, please note this. Some of you have given it is only bounded above. It is unbounded, but it is bounded above as well as bounded below. ఏమో కొంతమంది ఏదో ఇచ్చారు కదా నాట్ బౌండెడ్ అని ఈ లోయర్ బౌండ్ ఎగ్జిస్ట్ అవ్వదన్నట్టు చెప్పారు. ఇది ఎప్పుడైతే ఇలా ఇదేంటి డిక్రీజింగ్ సీక్వెన్స్, ఇలా డిక్రీజింగ్ టర్మ్స్ ఉన్నప్పుడు గుర్తుపెట్టుకోండి ఇది అప్పర్ బౌండ్ అయిపోతుంది మాక్సిమం. ఈ లిమిట్ ఆఫ్ ద nth టర్మ్ తీసుకుంటే వచ్చే వాల్యూ మీకు లోయర్ బౌండ్. అదే కనుక ఇది ఈ ఫామ్ లో ఉందనుకోండి, S1 లెస్ దాన్ S2 అండ్ సో ఆన్ ఇంక్రీజింగ్ ఆర్డర్ లో ఉన్నప్పుడు ఇది మీకు లోయర్ బౌండ్ అవుతుంది S1. ఈ nth టర్మ్ లిమిట్ తీసుకున్నట్లయితే అది మీకు అప్పర్ బౌండ్ ఇస్తుంది. అది ఇన్ఫినిటీ వచ్చింది అనుకోండి, దెన్ ఇట్ ఇస్ నాట్ బౌండెడ్ అని చెప్పచ్చు. ఫైనైట్ వాల్యూ వచ్చింది అనుకోండి, అది బౌండెడ్ అబౌవ్ అని చెప్పచ్చు. ఇది కొంచెం షార్ట్ కట్. నెక్స్ట్ చూడండి, ఫర్ ఎగ్జాంపుల్ n స్క్వేర్ చూడండి. n స్క్వేర్ తీసుకున్నప్పుడు Sn n స్క్వేర్ 1 స్క్వేర్ 2 స్క్వేర్ 3 స్క్వేర్ and so on. 1, 4, 9. What is the range of this sequence? Range of the sequence. All distinct values. All are distinct. So, what is the order therefore increasing or decreasing that we have to see? As we can see, 1 is less than 4, less than 9, and so on. Increasing. This is, and nth term is n square. Remember, nth term. This is the way I have shown you. This is lower bound. So, range of the sequence, that is Sn, the nth term is greater than or equal to 1 for all n, bounded below. Now, as I said, how to get upper bound? This n square limit, if you take, if it is finite, that will give you the upper bound. But here, n tending to infinity, n square will give you infinity square, which is infinity. So it is not bounded above because it is not finite value. It is bounded. So it is an unbounded sequence. Is an unbounded sequence. Unbounded sequence. So whenever you are getting like this greater than previous question, here, whenever it is like this will give you the upper bound. This will give you the upper bound. This is like this. This limit entering to infinity. If it is finite, that will become the lower bound. If it is minus infinity, then it is unbounded, not bounded below. But here, if you take this is in the increasing order, that's what we observe, some pattern, fixed order. So this is, if you take limit entering to infinity, n square is infinity. This is lower bound is 1, upper bound is infinity. So it is an unbounded sequence because it is not bounded. Yes, it is not bounded. Okay. 2 power n. Next one. I have given the question 2 power n. N tending to n equal to 110. 2 square, 2 cube, 2 power n. So this is, what is the range? Set of all different values. What are the different values of the sequences? This is 2, set 2, 4, 8, 2 square 4, 2 cube 8, 2 power n, and so on. Now again, bounded, it is, what is the pattern it is following? What is the order? Increasing order and decreasing order, that we have to check. It is in the increasing order. So this is the lower bound. So Sn is greater than or equal to 2. And we have to get the limit. As limit entering to infinity, 2 power n, standard limit, it is infinity. There is one standard limit that you should know. 2 power infinity is infinity. Limit means entering to. What is the standard limit is? Limit entering to infinity, r power n will be equal to 0 if mod r is less than 1. Then use this standard. That is 1 by 2 whole power n, 1 by 3 whole power n. So standard limit is 0. If this is less than 1, it is greater than 1, it will be infinity. Greater than 1, it will be infinity. If it is less than 1, mod r, then automatically it will be 0. Use the standard limit. 3 power n, limit entering to infinity is infinity. Okay, so if it is greater than 1, it's 0. So it is if and only if both the sets. So this is the, so it is infinity. Not bounded above, unbounded sequence. So sequence 2 power n is an unbounded sequence. And what type of where it is not bounded is not bounded, unbounded. And it is not bounded, unbounded sequence. And is not bounded. If it is not bounded, if it is unbounded, is it not bounded below, not bounded above, or neither bounded below nor bounded above? So that's what we were asked to test. So we can test. Okay. So this is what, how we define what is the boundedness. But boundedness and unboundedness can be defined in like application you can see in future using limit sums. Like convergent, every convergent sequence is bounded. So if the sequence is convergent or not, if you check, if it is convergent, automatically bounded. You need not do like this then. So it has got application later. At present, for the questions like this, you can directly do like this at present. Now, let us go for now original definition of limit of the sequence. Original definition, let us see. So what is meant by limit of the sequence? So limit of the sequence, some questions we are getting. Limit of the sequence. I'll give you some standard limits. Using them, we'll work out some questions. Interesting questions. Limit of the sequence. So when do we say sequence, limit of the sequence is L. So limit n tending to infinity. The sequence Sn is said to be equal to some L if given epsilon greater than 0. I'll explain what it is. There exists M. Some textbooks they say M is natural number. Some textbooks they say M is real number. Anyway, let us see. There exists M, a real number, such that M belongs to capital N in some textbooks is given. Whatever it may be, we'll get the same answer. Such that Sn minus L less than epsilon for all n greater than or equal to n. What is the meaning of this? Let us see. That is for n equal to m plus 1, greater than or equal to m means what? M plus 2 and so on. Up to m, less than m, we don't know. But from m onwards, it should get close to some real number. That is, Sn is getting close to L. What is meant by less than epsilon? By the way, let us discuss. What is meant by epsilon? A very small positive real number. Positive real number, small and larger compared to n. Compared to 1 lakh, 1 is very small. Compared to 10 rupees, 1 is valuable. So that is a relative term. So epsilon is a positive, smallest positive among all real numbers with respect to n. This is the smallest one. That is negligible, very close to 0, almost close to 0. If this is very small, this is still small. That means the difference between Sn minus L is very, very small. Very, very small means that is almost it is equal to 0. That means Sn is, the difference between them is very, very small means Sn is almost close to L. The difference between them is very, very small means they're close. You can say you and your friend are very close because differences are very less. You have your opinions, most of the opinions are same. So you say you are close to each other. Close to each other does not mean stamped 100%, but the differences are negligible. So Sn minus L, difference between them is very, very small. That means almost negligible. Negligible means it is Sn is very close to. So whenever, from which number onwards, not from n equal to 1, 2, 3 and so on, at least after some number m onwards, if it is getting close to L, then L is what is called the limit of the sequence. What is the meaning of this? Let us understand this. For example, this is minus 1 by 2. Let us say 1. Then let us say 3 by 2. Then afterwards, it is getting close to 4, let us say. That is, for example, 1.79, 1.8, 1.89, and so on. So as n is improving, it is getting close to some number. Negligible differences, as you can see. Originally, we cannot decide S1, S2, S3, we don't know. From 4 onwards, here no particular order. For example, I can have even 1 by 3 here, and so on. I can have some numbers. Here minus, here 1, 1.5, 0.3. So there is no particular order it is following. S4 up to S4. But from S5 onwards, it is following some order. What is the order? 1.79, less than 1.8, less than 1.89. It is getting close to some number. 1.911, 1.99 bar. That is 1.9999 and so on. So after certain number, it is moving towards a fixed number. What is that number to which it is fixed? It is moving towards a number called 2. So it is getting close to 2. As you can see, 1.99 bar. So it is getting close to 2. So this 2 is what is called limit of the sequence. This sequence. For this sequence, it is said to be, and so on. For this sequence, limit is said to be 2. Because it is getting close to 2. Not from beginning n equal to 1 onwards. From 4 onwards, not 4, 5 onwards it is following. So what is your n? From n equal to 5, 6, 7, and so on, Sn. N is this. Sn. So S5, S6, S7, n equal to 5, 6, 7 onwards, it is following some pattern. It is getting close to some number. This becomes the limit of the sequence. Limit of the sequence is said to be some real number L provided sometimes from the beginning it will be there. N equal to 1 onwards, it may be close to M. Sometimes in the beginning we are not able to predict, but afterwards it is following and moving towards this. So this is the required limit of the sequence. For example, why are you here? From the beginning, from childhood itself, you never expected that you will be here as a mathematics teacher. So you never had a goal in the beginning. Some will be having from the beginning, but some they never had. They might not have even imagined that they will settle down in mathematics field. But afterwards, you developed some interest because of some teacher or some circumstances or your maturity. Your interest differs from time to time. It changes. We cannot decide our goal in the beginning. So then afterwards, sometimes, then you change it. After your 10th class, you decided, let us have MPC. Then also you have not decided that you want to settle down in mathematics field. Afterwards, again, you had some, again, goal you have set. Now you have settled down, doing your PG in mathematics. Now you are moving towards, want to settle down in mathematics field as a faculty or something in the mathematics field. So that is the goal. So what is your goal now? You want to do PhD and enter into some field. Some people who do in PhD in mathematics, again, they settle down in software. We don't know where your destiny is. So, but now you are in mathematics field at present. Future, we don't know where you will settle down. At present, all of you have done MSc mathematics. So you are here in this group, attending my classes here. Because you want to clear your set, your CSIR, something. You want to do PhD in mathematics. Some of you want to settle down in this field as teacher. So all of you now have settled down a goal. Now you are in mathematics field. That is your limit. L equal to mathematics field. So you have settled down in mathematics subject. So this is the limit of the sequence. Sometimes when you go for some functions, lunch, dinner, some functions, when items are there, people will be scattered. When they go for lunch, you can observe dinner, people will be scattered. Once somebody says there is some item there, then one big queue will go there. That means in between they are scattered. Once you got the information that everybody is interested item is there, then there will be one big queue. So what is the limit point of that sequence? Is this object, item. Wherever the big queue is there, most of them, they will be scattered, of course, all will not be in one queue. So they may not like that item, but majority of them moves to some item. That is the limit of that particular dinner. That is where people are going. That is the item. That becomes the limit point of this sequence. S1, S2, S3, people are waiting. This item is the limit of that. It does not mean all are moving. Some are scattered to some other items also, but majority of them are moving towards that. This is N. Similarly here also. Some are scattered, but at least majority are towards some number. That number is what is called limit of the sequence. Okay, this is the basic understanding. Next, what's the application? We are interested not in knowledge, but we want to have knowledge also. Because if we become a teacher again, this is the topic where it is not taught correctly in the colleges. Therefore, I'm taking little bit time to explain the concept. At least you will give this concept to your students in future in the way it has to be. Okay, this is how the limit of the sequence is defined. So now we want to define for practical. That is, you want to apply it to the problems. Then how to apply? So limit of the sequence is defined as limit of the nth term. This is the general one. Wherever nth term goes, that is as n tends to infinity from m onwards, wherever this term is approaching, all the terms will approach that only. That fix that number towards which it is there. That is what is called limit of the sequence. Sometimes, not only one item, more than one item, one big queue will be. There can be two favorable items. More than two favorable items. Big queues will be there in this. Then limit is not unique then. If they all are moving towards only one item, that is limit is unique. But some will be moving here, some will be moving here. Majority of them got streamlined into 2 to 3 queues. Then these three are limit points. So limit of the sequence need not be unique. There can be more than one limit for the sequence. So one important thing to be observed is it should be L. This L can be infinity. Some students they think L must be finite. No, L is any real number. So L may be finite. L may be infinite also. L may be minus infinity also. So we don't say limit does not exist. Limit exists. And what is the limit of the sequence? L infinity minus infinity. Why this confusion is? In your real analysis, for the functions, when you define limit of the function, there you might have studied limit if it exists must be unique. If the limit is not unique, then it does not exist. You study in real analysis. That is for sets, limit of the sets. So generally students that get branded in the mind, they think, okay, if the limit is not unique, for the sequence also it does not exist like that. No. Sets కి అయితేనమ్మా గుర్తుపెట్టుకోండి లిమిట్ ఆఫ్ ద ఫంక్షన్. లిమిట్ ఆఫ్ ద ఫంక్షన్ వేరు, లిమిట్ ఆఫ్ ద సీక్వెన్స్ వేరు, లిమిట్ ఆఫ్ ద సెట్ వేరు. మనం లిమిట్ పాయింట్ ఆఫ్ ద సెట్ నేర్చుకున్నాం ఫండమెంటల్స్ లో. అక్కడ ఓపెన్ సెట్స్ క్లోజ్డ్ సెట్స్ వచ్చినప్పుడు అక్కడ ఒక లిమిట్ పాయింట్ మనం నేర్చుకున్నాం. లిమిట్ పాయింట్ ఆఫ్ ద సెట్ నేర్చుకున్నాం అక్కడ. ఆ లిమిట్ పాయింట్ వేరు. లిమిట్ పాయింట్ ఆఫ్ ద సెట్ ఈస్ డిఫరెంట్, లిమిట్ ఆఫ్ ద ఫంక్షన్ ఈస్ డిఫరెంట్. ఫంక్షన్ కి అయితే ఎట్లా చేశారు? మీరు 10th క్లాస్ లో ఇంటర్ లో చేశారు. ఈవెన్ డిగ్రీ కోర్సెస్ లో ఎల్హెచ్ఎల్ కనుక్కుంటారు. లెఫ్ట్ హ్యాండ్ లిమిట్, రైట్ హ్యాండ్ లిమిట్. ఇఫ్ ఇట్ ఈస్ ఈక్వల్ వి సే లిమిట్ ఎగ్జిస్ట్, నాట్ ఈక్వల్ లిమిట్ డస్ నాట్ ఎగ్జిస్ట్ అని చెప్తాం. ఎందుకంటే ఫంక్షన్స్ కి అయితే కనుక లిమిట్ ఇఫ్ ఇట్ ఎగ్జిస్ట్ మస్ట్ బి యూనిక్ అనే కాన్సెప్ట్ ఉంది అక్కడ. అక్కడ మనం వెళ్ళినప్పుడు అది కూడా అలా చెప్తాము. దట్ ఈస్ లిమిట్ ఆఫ్ ద ఫంక్షన్. మనం ఎఫెక్ట్స్, లిమిట్ ఎఫెక్ట్స్ అక్కడ మనం చదువుతున్నాం. లిమిట్ ఎక్స్ అప్రోచింగ్ ఏ ఎఫెక్ట్స్, లిమిట్ ఎక్స్ అప్రోచింగ్ ఇన్ఫినిటీ ఎఫెక్ట్స్, అది లిమిట్ ఆఫ్ ద ఫంక్షన్. అది వేరే. లిమిట్ ఆఫ్ మనం నేర్చుకుంటున్నది ఏంటి ఇక్కడ? లిమిట్ ఆఫ్ ద సీక్వెన్స్. సో ఏ కాంటెస్ట్ లో దాన్ని ఫాలో అవ్వాలి. లిమిట్ పాయింట్ ఆఫ్ ద సెట్ ఆల్రెడీ మనం నేర్చుకున్నాం, అది వేరు. ఇప్పుడు మనం చేస్తున్నది ఏంటి? లిమిట్ ఆఫ్ ద సీక్వెన్స్. సో ఇప్పుడు ఈ కాన్సెప్ట్స్ ఏమైనాయి అంటే మిక్స్ అయిపోయి చాలా మంది ఏం చేస్తున్నారు, సపోజ్ లిమిట్ ఎంటెండింగ్ టు ఇన్ఫినిటీ ఎస్ అని ఇన్ఫినిటీ వచ్చింది అనుకోండి, ఇంకోటి ఉంది మనకి ఇది డస్ నాట్ ఎగ్జిస్ట్ అని. సో అది కాదు. లిమిట్ ఈస్ నీడ్ నాట్ బి యూనిక్, లిమిట్ ఆఫ్ ద సీక్వెన్స్ నీడ్ నాట్ బి యూనిక్. దేర్ కెన్ బి 2 to 3 లిమిట్స్ అండ్ ఇట్ కెన్ బి ఇన్ఫినిటీ, it can be minus infinity. So very important thing is limit of the sequence need not be unique. If it is unique and finite, then it is said to be convergent. అక్కడ కన్వర్జెన్స్ దగ్గర వస్తుంది. లిమిట్ ఎగ్జిస్ట్ అవ్వడం వేరు, కన్వర్జెంట్ వేరు. సో ఫర్ ద లిమిట్ టు ఎగ్జిస్ట్ it need not be finite only. Limit of the sequence can be finite or it can be infinity or it can be minus infinity also. లిమిట్ అనేది యూనిక్ కానవసరం లేదు, ఫైనైట్ కానవసరం. ఇది కొంచెం షాకింగ్ కొంతమంది, ఎందుకంటే మీరు అక్కడ నేర్చుకున్న ఫంక్షన్స్ ఇక్కడ అప్లై చేస్తారు తింటారు. సో ఇంపార్టెంట్ అమ్మా ఇది. లిమిట్ నీడ్ నాట్ బి ఫైనైట్, లిమిట్ నీడ్ నాట్ బి యూనిక్ ఆల్సో. సో దట్ ఐ విల్ రైట్. సో నోట్ వెరీ ఇంపార్టెంట్ పాయింట్. లిమిట్ ఆఫ్ ద సీక్వెన్స్ వెన్ యూ ఫైండ్ అవుట్ ఎల్, sometimes it may be but not necessarily, where L need not be unique. Number one, there can be more than one limit. L need not be unique. L need not be finite. And it can be infinity, it can be this also. Need not be finite. It can be infinity also. Still we say limit exists. Okay. So we'll try to use this for finding our M value. Sometimes you are getting questions like this. In one of the, I think, set paper I have seen. క్వశ్చన్ ఇక్కడ నుంచి ఎట్లా వస్తుంది అంటే లిమిట్ ఎంటెండింగ్ టు ఇన్ఫినిటీ 1/n². మీకు ఇచ్చేస్తారు అమ్మా epsilon is equal to, let us say, 0.1. 0.01 మీకు ఇవ్వచ్చు 1 స్క్వేర్ 0. మీకు 10 అని కూడా ఇవ్వచ్చు. ఎనీ నెంబర్ ఇట్ మే బి. దెన్ m is you may be given the question, if modulus of 1 by n square minus 0 is less than epsilon for all n greater than or equal to m, then m is or values of m. Like this, options will be given. So how to work out this question? So let us see. Limit 1 by 1 by n square is 0 also means this is like your L implies given epsilon. ఇది ఇస్తే ఇది రాయక్కర్లేదు. Given epsilon, definition says there exists an m such that and a real number L is already given to you such that what is the condition? 1 by n square minus 0 less than epsilon. That is 1 by n square less than epsilon. Which implies, because modulus of positive number is itself, I can remove modulus sign because n square is positive, n is positive. So we want n value, n is greater than 1 by root epsilon. Of course, modulus will be there. I want only this side, so I'm taking only that side. So it will be between minus root epsilon and plus. This is 1 by root epsilon. Absolutely. I want to find out what is n value. N is greater than 1 by root epsilon. Positive square root of this. And n greater than or equal to m. We have this. We want to solve these two equations for m. How to get your m? It has to satisfy both. So, when are both going to be satisfied? Provided n is greater than or equal to m, and m should be greater than 1 by root epsilon. I cannot have is equal to. Why? Because strictly greater than whenever you are having, either here it should be strictly greater or here it should be strictly greater or both. Okay. So here equality is given in the definition itself. I cannot remove it. Therefore, strictly greater than, suppose I am having this here also equal. Here it will have equal. But it is strictly greater. That means here I cannot avoid. Here I should have strictly greater. గుర్తుపెట్టుకోండి, స్ట్రిక్ట్లీ గ్రేటర్ అన్నప్పుడు ఒక ట్రాన్సిటివ్ రిలేషన్ ఉన్నప్పుడు అయితే ఇక్కడైనా స్ట్రిక్ట్లీ గ్రేటర్ ఉండాలి, ఇక్కడైనా స్ట్రిక్ట్లీ గ్రేటర్ ఉండాలి, రెండిట్లోనూ స్ట్రిక్ట్లీ గ్రేటర్ ఉండొచ్చు. అట్లీస్ట్ వన్ ఆఫ్ దమ్ షుడ్ హ్యావ్ దిస్ సింబల్ గ్రేటర్ దాన్, అప్పుడే ఇది గ్రేటర్ దాన్ ఉంది. లేకపోతే గ్రేటర్ దాన్ ఆర్ ఈక్వల్ టు అని వచ్చేసి we want our m to satisfy this condition. Then automatically both the inequations will be satisfied. You can see n greater than equal to m, this is satisfied by transitive property. A greater than b, b greater than c means a greater than c. So this is also satisfied. So both are satisfied for this. Now I want to find out my m value. So given epsilon. For example, epsilon is given to be, and the chair first thing, epsilon will be given to you, given in one of the papers. If epsilon is going to be 0.1, 0.01, రెండు. So రెండు కేసులు చేద్దాం. 0.1. This is for your practice. 0.1. 0.1 means so this is 0.1. That is 1 by 10. 0.1 is 1 by 10. So m should be greater than 1 by root epsilon. So what is root epsilon? 1 by root 10. What is 1 by root epsilon? Reciprocate, root 10. So n should be greater than or equal to m. M is greater than root 10. So what is the integer? Greatest integer, not less than or equal to. We want to find out the greatest number. That is what is the first number otherwise? M greater than root 10. M can be anything greater than root 10. So if M, what is the next integer? What is the next natural number after root 10? What is root 10? It is almost 3 point. It is between 3 and 4. Definitely. Root 9 is 3. Root 16 is 4. Between 3 and 4. So after root 10, what is the natural number? First natural. M is greater than root 10. That means M has to be greater than root 10. What is the natural number after 3? Between this sentence, greater than root 10, this is M is between. What is the next natural number? How to get that is, you take box. What is box? Greatest integer, not less than or equal to root. Greater than this. So what is the next number which is greater than this? Its integer is 4. This is 3.3, let us say, 3 bar. What is the integer greater than that? M is greater than 3.3 bar. 3.3, 3.33, anything. What is the integer after this? 4. What is the natural number after this? 4, 5, 6, 7. So if you say M is real number, then there are many values. M can be 3.3 bar open up to infinity. These are the values M can take. If M is real number, 3.3 bar open. Open means I cannot take because strictly greater. What are the values M takes? 3.31 bar next number. Whatever it is. Up to infinity, all are values for it. If you want natural number, then 4, 5, 6. Because after 3.3 bar, what is the next natural number? Obviously, 4. So 3.3 bar is approaching 4, 5, 6. What is least among them? 4. So generally, M is taken as the least among the numbers which are greater than this. So among options, for example, M is, suppose you are given option A, 2, option B, 3, option C, 5, option D, let us say 10. Then what are the values of M? Values of M are, what are the values M can take? Anything greater than 4, greater than or equal to 4. So this is not greater than 4. This is not greater than 4. 4 onwards, any number. Because if I take M greater than 4, any number it can be. If it is 4 also greater than root 10, 5 also greater than root 10, 6 also greater than root 10. Anything. So what are the values M can take? 4, 5, 6 and so on. It is not unique. There are many values, infinitely many M exist. How many M exist? Infinitely. So among the options, 4 is given, correct. 5 is given, correct. Anything greater than root 10 is M. So greater than root 10 means it can be 4, 5, 6 and so on. So it cannot be 2, it cannot be 3, it cannot be 3.3 bar also. So it should be 5, 10 also. Because it is greater than anything greater than root 10. That is the answer. So in some textbooks, in the international editions, they take it as natural numbers, M as natural number. In our Indian edition, some editions, they take it as real number. Whatever it may be, formulate the relation. Look at the options. Among the options, whichever satisfies this is the requirements. Among them, which satisfies is 3 is not greater than 3.3, 5 is greater than 3. This root 10, 10 is greater. So these are the options. This is how we can predict M. One more is given. For the given M, epsilon, you can find M. What is the epsilon that is given? 0.01. If epsilon is 0.01, then M is, are the values of M. So, second one, M is 0.01. Sorry, epsilon. 0.01. That is 1 by 100. So root epsilon, 1 by root 100. I'm taking positive. It has to be natural number. So I'm taking that 1 by 10. 1 by root epsilon. So 10. So let us go for this. I want what is the relation? N should be greater than or equal to M. M should be greater than 1 by root epsilon. That is 10. 1 by root epsilon, I got it. That is M should be greater than 10. So depending on the question, whoever sets the paper based on it. So if M is given to be natural number, then this will be specifically given to you. What are the values? 11, 12, and so greater than 10 natural numbers. If M is real number, then what are the values? M takes. What is the next number after 10? We don't know. After 10, what is the next real number? We don't know. So M is between 10 to infinity. 10, 10.1, 10 it cannot take because strictly greater. 10.1, 10.01, 10.11, anything up to infinity. So what are the values of M? Values of M are suppose you are given question. Options are given to you. 10. Let us say 20, 25, 9. Then you have to decide. So you should not opt 10 because 10 cannot be greater than 10. Greater than 10 it has to be. So it is not valid. 20 is okay. Greater than 10. 25 greater than 10. Suppose decimals are given greater than 10. That means they are taking it as real. That is also correct. For example, if I take E as some 10.9 bar, then this is also correct. That means M is given to be real then. If M is given as natural number, only these two are correct. M is given as real, description will be given to you. 10.9. This is also correct. If M is real. If M is natural number, only B and C options correct. So based on the question, look at the options which are given to you. Specifically, M specification will be given to you. First, you have to observe that also. So is M belonging to N given or M belonging to or nothing given? So then look at the options and then answer accordingly. Okay. So this is one of the best applications you might not have seen in your courses, regular courses, but you are definitely getting questions in your set. Definitely. One question or more. So such questions also we should work out. I'll try to work out some more. Now, is it clear for us? I want to know your opinion because I have been running like a Chaitanya Narayan advertisement. So I want to know whether are you following or am I running? Are you catching the speed?
Yes. Anyone?
Em-
Thank you, madam. Nice lecture.
ఏమైనా డౌట్స్ ఉన్నాయా?
మేడం చాలా బ్యూటిఫుల్ గా బౌండెడ్ అన్బౌండెడ్ లిమిట్ కాన్సెప్ట్ అనేది ప్రజెంట్ సిచ్యువేషన్ లో టీచర్స్ కి ప్రాబ్లం వచ్చేసి అక్కడ చెప్పలేకపోతా ఉన్నారు. ఎక్స్ప్రెస్ చేశారు ఎం వాల్యూ గురించి. ఇక్కడ ఈ ప్రాబ్లం లో కూడా మనకు ఇప్పుడు సీక్వెన్స్ అండ్ సిరీస్ లో సేమ్ ప్రాబ్లమ్ షో దట్ లిమిట్ 1/n² = 0 ప్రూఫ్ చేయమంటాడు. ఈ కండిషన్స్ వాడుకునే బేసిక్ డెఫినేషన్ వాడుకునే ప్రూఫ్ చేస్తూ ఉంటాడు. బట్ కొంతమందికి ఆ టెక్స్ట్ బుక్ లో ఎందుకు అలా చేస్తున్నాడో ఏందో తెలియదు.
అవును,
చాలా నైస్ గా ప్రజెంట్ చేశారు మేడం.
ఇది గ్యాప్ ఉంది.
యా,
దిస్ ఇస్ ద గ్యాప్ యూఆర్ హ్యావింగ్. సో ఇది ఒకసారి ఎవరికైనా డౌట్స్ ఉన్నాయమ్మా? డౌట్స్ ఉన్నాయా?
ఈ ఈక్వేషన్ పైన n ≥ m > 1/√ε ఈక్వేషన్ ఎలా వచ్చిందో అడుగుతున్నాను మేడం. పైకి వెళ్ళండి.
ఇదే పైకి. ఇది ఎలా వచ్చింది అంటే ఇంతకు ముందర చెప్పాను, అక్కడ మీరు మిస్ అయినట్టున్నారు. ఒక్కసారి చూడండి. ఇక్కడ మనకి కండిషన్ డెఫినేషన్ ఏం చెప్తుంది? డెఫినేషన్ అకార్డింగ్ టు డెఫినేషన్ ఎస్ఎన్ షుడ్ బి ఇది డెఫినేషన్. మనం స్టార్టింగ్ నేర్చుకున్నాం. లిమిట్ Sn = L means Sn - L should be less than or equal to less than epsilon n greater than or equal to m. ఇది ఒరిజినల్ డెఫినేషన్. సో వాట్ వీఆర్ ట్రైంగ్ టు ఫైండ్, వీఆర్ ట్రైంగ్ టు సాల్వ్ దిస్ ఇన్ఈక్వాలిటీ. ఈక్వేషన్స్ అయితే ఈజ్ ఈక్వల్ టు సాల్వ్ చేస్తాం. వీఆర్ ట్రైంగ్ టు సాల్వ్ ఇన్ఈక్వాలిటీ. హౌ టు సాల్వ్ an inequality? We have to solve this Sn minus n equal to less than epsilon. So we are taking 1 by n square minus 0 less than epsilon. This should be less than epsilon. When is it possible? When this is possible. This is possible whenever this is possible. ఇక్కడ నేను when అని యూస్ చేస్తే బాగుంటుంది, implies కదా. So whenever, this will be the correct expression. Whenever 1 by n square is less than epsilon. This is whenever 1 by n square is, because n అనేది natural number, n square positive కనుక I have removed the morphemes. Whenever epsilon is less. This is possible whenever this is greater than this. n is greater than root epsilon, ఇక్కడ నుంచి వచ్చింది మనకి. And n greater than or equal to m, basic definition. What is our problem? We have to get m which is satisfying both. When are both going to be satisfied? Provided n is greater than or equal to m and m is greater than 1 by 2. ఈ కండిషన్ అయితేనే ఇవి రెండు సాటిస్ఫై. When are these two conditions going to be satisfied? Only whenever n is greater than or equal to m and m is greater than 1 by root epsilon. Only these two will be satisfied. They will be satisfied. Both are satisfied whenever these two are satisfied, whenever this is satisfied. So from here we got the condition. ఇక్కడ నుంచి మీకు అర్థమైందా? ఎవరు అడిగారు? ఓకేనా? ఈజ్ మై ఎక్స్ప్లెనేషన్ ఓకే?
Yes.
ఏమా?
Yeah. Anyone respond? ఎలా ఉందమ్మా క్లాస్? ఎలా ఉంది? ఓకే, ఫాలో అవుతున్నారా? రీడర్ అండ్ ఇంగ్లీష్ లో మేడం మళ్ళీ తర్వాత తెలుగులో కూడా చెప్పారు. మంచి కాన్సెప్ట్ కాబట్టి లిమిట్ కాన్సెప్ట్ వచ్చినప్పుడు తెలుగులో కూడా డిస్కస్ చేశారు. సో మోర్ ఓవర్ మేడం మా యొక్క ఇంటెన్షన్ ఏంటంటే టీచర్లకు ఫస్ట్ తెలవాలి. అక్కడ బుక్లలో చాలా మంది కనిపిస్తారు. పిల్లవాడు అంతసేపటికి ఏముందిలే సేమ్ whenever mod 1 by n square is less than epsilon ఆన్సర్ వచ్చేసింది యాజ్ డెఫినేషన్ ప్రకారం. అట్లా కాకుండా చాలా బ్యూటిఫుల్ గా ఎక్స్ప్లెయిన్ చేశారు మేడం. మీకేం డౌట్స్ ఉంటే అడగండి. సంతోష్ కుమార్ గారు
అడగండి అండి, ఏమైనా డౌట్స్ ఉంటే అడగండి. అయితే స్పీడ్ ఓకేనా? ఇంకొంచెం తక్కువ చెప్పాలా? తెలుగులో ఇంకా చెప్పాలా? అదర్వైజ్ ఓకేనా? మీరు అడగచ్చు. ఎందుకంటే యూ హావ్ ఎవరీ రైట్. మీకు అర్థం కావడం ముఖ్యం. మా గోల్ రీచ్ అవ్వాలి, మీకు అర్థం కావాలి.
థ్యాంక్ యూ మేడం.
క్లియర్ గా ఉంది మేడం.
క్లియర్ గా ఉందా? ఓకే, థ్యాంక్ యూ సో మచ్. రేపు కలుద్దాం అండి.
థ్యాంక్ యూ మేడం. అరౌండ్ 85 మెంబర్స్ విన్నారు మేడం ఫైనల్ గా మనకు. ఎక్సలెంట్. ఆల్ ద టీచర్స్ 85 మెంబర్స్ మాక్సిమం. మినిమం ఈజ్ 51 మెంబర్స్. ఎక్సలెంట్ క్లాస్. అరౌండ్ 1.5 hour 1 hour 44 minutes అయింది. థ్యాంక్ యూ మేడం. థ్యాంక్ యూ వెరీ మచ్.
థ్యాంక్ యూ సార్.
గ్రేట్ సర్వీస్ అనుకుంటున్నాము.
అయ్యో అదేం లేదు సార్. Propagation of maths.
థ్యాంక్ యూ వెరీ మచ్.
Thank you. Tomorrow will.
గుడ్ నైట్ ఆల్ ఆఫ్ యూ. సో క్లాస్ లో కలుద్దాం. థ్యాంక్ యూ మేడం. అది షేర్ చేయండి మేడం నోట్స్ అది.
ఓకే, ఇప్పుడు చేస్తాం.
గుడ్ నైట్ ఆల్ ఆఫ్ యూ. ఇంకేమైనా డౌట్స్ ఉన్నా మీరు ప్రిపేర్ అయిన తర్వాత నెక్స్ట్ కమింగ్ క్లాస్ లో ఇంకా చదవండి. సో రియల్ అనాలిసిస్ అంటే వినేటప్పుడు చాలా బ్రహ్మాండంగా అనిపిస్తూ ఉంటుంది. ఓకే, గుడ్ గుడ్ అంటాము. దెన్ మళ్ళీ డౌట్స్ వస్తాయి, అవి రావాలి, మీరు అడగాలి. గ్రేట్. సో మీకు వాట్సాప్ గ్రూప్ లో కొన్ని క్వశ్చన్స్ పెట్టాము ఇంతకుముందు. చాలా మంది చాట్ బాక్స్ చేస్తారు. ఈజ్ ఎవ్రీ ఇంక్రీజింగ్ ఫంక్షన్ ఈజ్ అన్బౌండెడ్ above, every decreasing function is unbounded below అని క్వశ్చన్ ఇచ్చాను. ట్రై చేయండి, మళ్ళీ గ్రూప్ లో పెడతాను, చాట్ బాక్స్ లో పెడుతున్నాను. ఈజ్ ఎవ్రీ ఇంక్రీజింగ్ ఫంక్షన్ is unbounded above? Yes or no? Is every decreasing function is unbounded below? ఒకవేళ అయితే ఎగ్జాంపుల్ ఇవ్వండి. రైట్. సో చాట్ బాక్స్ లో నెక్స్ట్ క్లాస్ లో మళ్ళీ మాట్లాడతాం. రైట్. గుడ్ నైట్ అలా.
సార్ 1 minute సార్.
సంతోష్ గారు చెప్పండి.
సరే సార్, లింక్ కొంచెం ఒక 5 minutes బిఫోర్ పంపిస్తారా? కొంచెం ఇబ్బంది అవుతుంది.
యాక్చువల్లీ నేను మర్చిపోయాను, మీరు చెప్పలేదు. ఒక లింక్ పెట్టాను నేను, అది వేరే లింక్ వచ్చినట్టుంది. ఓకే, గుడ్ గుడ్ గుడ్. మీరు రికార్డింగ్ సెషన్ వినండి. వెరీ గుడ్ సంతోష్ గారు. సార్ వెయిట్ చేస్తా ఉన్నారు, నేను డిలే చేశాను. ఓకే, ఇంకేమైనా డౌట్స్ ఉంటే కూడా నెక్స్ట్ క్లాస్ లో మీరు అడగండి. నో ప్రాబ్లం.